Hello everyone. In this session we learn about gradient descent and backpropagation in neural networks. In my previous sessions we discussed about what are the neural networks, types of neural networks, how neural networks lens data. In the learning process we discussed about how forward propagation is performed with weighted sums and activation functions. A network basically learns from the data by looking at the features, and weights are assigned to edges. So in forward propagation we move from input layer to output layer, hidden layer process through different weights. Finally we predict the data whether this belongs to A, B or C categories. How much prediction means when we are predicting something, there is a chance of some loss in that prediction. Means we expect some target and our prediction may not go as per the target. So then again this network relearns by adjusting its weights through gradient descents and back propagations. So this is one of the important process in learning process of a neural network. So in gradient descent basically it's a optimization algorithm that is used to find the minimum of a function. Here function means it may be a cost function or loss function that is predicting how much error is there between the prediction and our target. So this gradient descent finding this minimum is done through the back propagation method. That back propagation calculates gradients of that function at respect to the model's parameter. So let us understand this, how this what is this gradient descent basically through a small example. Suppose we have a friend, we attempted a test, and your friend has attempted a test and your friend got some result. Now you ask him how many marks he got. You know that marks may be maximum marks are 100, and you know his capability. He said that you asked how many marks he got in the exam. Now your friend rather than directly telling the marks, he asks you guess how many marks I got in the exam. You know about your friend, so you might have told him some 80, 70 something, 70. Your guess is 70 and your friend is say that no, that is not a correct answer. Target is actual value is the target value, but my prediction is 70. No, then correction. What I do, I add some more 5 marks to his, and again I ask and I tell him that you might have got 75 marks. Now friend says that that is also not correct. Now you may add some. Now you add 10 marks and you tell that you might have got 85 marks. Now he says that that is not correct. So maybe you reduce 5 and you may say 80. Now your guess is correct guess, and he says that is correct. Means you got 80 marks, that is correct. Means here your prediction matches with your original target value. Means is a target value, actual value. Now what we have done here, I added 5, added 10, then I reduced 5. This is nothing but these are learning parameters. Here also similar way my neural network is learning from the data and giving the output as a prediction. My prediction should match whether should match with the target. No, here every time I made there is a loss. That means here when I gave 70, there is a loss of actual marks are 8, target is 80, there is a loss of 10. Means whenever I give a new number, I try to minimize this loss. Means it should reach towards the value. So this hyperparameter should be adjusted so that measuring value should be less. Means so when 70 as told his marks are 80, I should not go that you got a 30, means there is a lot of I should my guess should reach towards the actual value, means minimize the loss. So The same concept we use it as a gradient, gradient descent in our network, where prediction is not correct. What we do, again to minimize that loss, again we use a backpropagation techniques in the backward direction, and we adjust the weights. Again goes for relearning on the data. So your gradient descent, basically it's an iterative algorithm, use it to find the minimum of a function, nothing but your cost or loss function. It works by taking steps in the direction of opposite to the gradient of the function at that current point. The size of each step is determined by the learning rate, which is hyper parameter. Here means plus 5 plus 10 is nothing but a hyper parameter. Now backpropagation actually finds gradients at each level. It's an algorithm for calculating gradients of the loss function with respect to the network's weights and biases. See, weights means in forward propagation we assigned weights. Which weights are contributing to the loss function? If I reduce those weights, I may get the correct predictions, means the derivatives I am finding on those weights. So the calculation done by propagating the error signal backwards through the network. The chain rule of calculus is used to compute these gradients layer by layer, starting from output layer and moving back to the input layer. Let us see a small example how this backpropagation gradient works. Suppose I have a network where 2 input layers are there, 2 hidden layers and 1 output layer. So example, assume a neural network. Here there are 2 hidden, there is 1 hidden layer, 1 input layer, 1 output layer. In hidden layer 2 neurons and input layer 2 neurons are there. So activation function, I am using a sigmoid function. That means your activation function either gives zeros or ones. So I set a learning rate as a learning rate is 1 and my target is 0.5, means when this output layer I expect 0.5 at this layer. Now let us go through one by one. Initially I gave some random weights to the network. In forward pass I calculated weighted sum and I pass it to a activation function. So like this, at every layer, at every point I calculated output. Here y3 output, y4 output, y5 output as a output of my activation function. Just go through. Weighted sum is calculated with the feature value. Here x1 feature is 3.5, means these features have some, while taking predictions we give more importance to some features and less important to some other features. Based on that I give some values now. 3, 7, like here I calculated outputs at y3, y4. Now finally in the forward propagation I got my final value as 0.69. So here my final Wi-Fi value is 0. See, initially first I calculated y3, y4 here. Y3 f of a1, a1 is nothing but weighted sum with the features of x1 plus x2. I calculated 0.6 and 0.66 as y3 and y4. With this help again I calculate Wi-Fi. Now when I Wi-Fi, my sigmoid activation function gives its value as 0.69, but at the starting of the problem I set my target is 5. So how much difference I have there? So you can, error is there minus 0.19. Now we have to minimize this error. So to minimize this error, now I start a back propagation. So in back propagation I use the formula, a derivative. So y into 1 minus y target minus y value at each. First we start from output layer. From output layer we go to the hidden layers, from hidden layers to the starting original weights. So I use the formula y into 1 minus y by y target minus y. So at this place, difference, how much value of this y contributed to the error I calculated here. So here my actual value is 0.69. So 0.69 into target value 1 minus 69. So here I got y5 as 0.69. 0.69 into 1 minus 0.69 into my target is 0.5 and my actual is. So when I at this output layer y5 is 6.9. So here I measured it gradient as minus 0.04%. Now I take this value and I back propagate it to the next hidden layer. Hidden layer is that here I calculate gradient at delta 3. It says that y3 into 1 minus y3, this formula nothing but back propagation formula here I am using, y3 into 1 minus y3 into w35 into delta 5, means for this output how much to get this much difference, how w35 contributed to get this difference. I am calculating gradient at this layer. So here it has minus 0.2. Like this at every level y3, y4 I calculated. So by taking these back propagated, how much weight these how these weights affected that value, again means at each layer in backward I am calculating for that loss how much each neuron is contributing. So after that I adjust a new weights, as a new weights is equal to difference weights of 4, 5 plus its old value. So like that I calculate new weights and again I relearn, again I go forward. Now this target is 0.5, earlier 0.6, it may reduce the value. Like this we have to repeatedly apply this process until we reduce minimum between the target and actual value at this prediction layer. Like this forward propagation and backward propagation. Forward propagation happens until my network learns the correct prediction. This is how gradients are calculated at each neuron and with the how weights are contributed, those gradients are calculated and new weights are adjusted, old weights are adjusted with the new values and network learns about the data. How this is how a neural network learns from the data sets. Thank you.